Hi, it's Alan and Emily here from Science in a Van, coming to you live from a shed at 275, the beautiful South Auckland. We have a fantastic show lined up for you today. It's dedicated to all the teachers out there, but we're going to have heaps of fun, give you heaps of demos and ideas you can take back in your classroom, and of course we're going to end with Geography Day.
Kia ora e te whānau. Yes, we are Science in a Van, and this is Science in a Van Live. We travel all around the country delivering our engaging, fun science shows to primary and intermediate schools. We've actually been going since 2011. It's crazy, I know. We're so lucky that throughout all these years we blow giant bubbles bigger than a 2-year-old, talk about mixtures, we fire rubber chickens and water rockets, talk about forces. We have a really good time.
Yep, we aim to deliver science in a fun and engaging way. And today's video is all about our show, What's the Matter? This is actually one of a 4-part series of videos giving overviews to educators about what our shows are and the subjects that we cover. And we're going to show you some of the demos from the show, and we're also going to give you some ideas and activities you can take back to your classroom.
So by the end of this video, you'll know all about the science show, What's the Matter? You'll have the confidence to go back to your classrooms after the show and lead some really interesting discussions. We're going to show you a couple of experiments from the show that you can do in your classroom to recap. And today, we've got a little bit of super extra special content.
So, What's the Matter is designed for years 4 to 8, and it covers the material world part of the science curriculum. And in the 45-minute show, the students will feel more confident in investigating and talking about things like the properties of materials, how we experience materials, how materials change through the states of matter, and how that all relates to something known as a periodic table.
It's a big subject, right? And we do all that in what, 45 minutes?
45 minutes and in one breath, like I just did. There we go.
Well, we breathe a little bit more during the show, but don't worry. And all our science shows, we really like to start simple. And in the What's the Matter show, we totally start simple. We start with something that most kids are familiar with, to be fair, the 5 senses. Now, our 5 senses help us to understand the properties of materials, which is really important. So, for example, this feather, what does it look like?
It's yellow.
Very good. What does it sound like? That's a bit of a weird one. What does it feel like?
Oh, it's hairy.
What does it taste like? Don't do that.
I don't want that.
So we've done sight, hearing, smell, taste.
Yep.
We're done.
We're done.
Yeah, sorry, always forget. So we experience materials through our senses, and that helps us understand the properties of materials. Now, we also do sort of silly questions, which are quite good. For example, why is this not a piece of ice cream? I know, Alan's not eating it for a start, but you can see where we're going. It's a really fun way to start the show, a really nice hook. Then we move on to the states of matter. Now, that's quite fun too, because up and down the country, there is a lot of debate about how many states of matter there actually are. I know. And we mostly talk about solids, liquids and gases, but to understand the 3 states of matter that we're talking about, we need to know what materials are made of. So, I know, it's kind of important. Now, everything in the universe, as far as we know, is made out of atoms. When atoms come together, they make molecules. Now, atoms are actually so small we can't see them, but they're the smallest identifiable part of a material. Right.
Smallest identifiable part of a material is an atom of a molecule.
Yep.
Right, okay, I've got it.
We don't go into this during the What's the Matter show, but it's good for you to know that atoms are made out of 3 main parts. They're made out of protons, neutrons, and electrons. Now, you can go smaller because kids are fascinated with something called quarks. Anytime you mention atoms to kids, they go, what about quarks? Fascinating. Now, there's a lot of debate about quarks too, and in fact, scientists are even debating if they even exist. So, quarks will come up. Be prepared for that. But what you really need to know, the cruncher is, everything in the world is made up of atoms when they come together, they make up molecules, and they're the smallest identifiable thing. They're so small we can't see them, but they are the building blocks for the universe. And we need to know about atoms and molecules because in solids, liquids, and gases, they behave differently.
Ah, right, yes, that's right. So here I have a jar of lentils. Now, if we imagine that all these lentils are either atoms or molecules, okay? And so all these lentils are atoms and molecules. If we look, they are close together and they are not moving. This is exactly how the atoms and molecules behave in a solid. They're close together, they're not moving, they're bored. But heat is energy. Heat is energy. Now, if I start shaking these, the atoms and the molecules start to move. They start to move around each other, and that. This is exactly how the atoms and molecules behave in a material, behaving like a liquid state of matter. So they're moving around each other and all of that. However, if I add more heat, more energy, and start shaking them, they're free flowing, they go all over the place. And this is exactly how the atoms and molecules behave in a material that is acting like a gas state of matter. Now, this is a very simplistic explanation of something quite complicated, but it shows us that when a material changes from a solid to a liquid to a gas, it's to do with the space and energy between the atoms and the molecules. So it's to do with the space and energy between the atoms and molecules as it changes from a solid to a liquid to a gas.
You wouldn't want to take the lid off when you gas.
Oh no.
They would just go everywhere. Now this is a great demo to help you, and others to be honest, and your students to imagine something that you can't actually see, right? Great demo. Another thing you can do to help them remember the common states of matter. Now, this is going to give you some serious street cred. Are you ready, Alan?
Yep.
Solids, liquids, gas.
There we go. Let's do that again. Let's go. Solid, liquid, gas.
You can see how cool we are. Anyway, another thing you can do, we've seen teachers do that to get your kids in the headspace of it. It's an activity, you could be on the netball court, teacher yells out, solid, and all the kids come close together really quickly and freeze. So they're all close together, they've got no energy. Teacher yells out, liquid, they kind of run around, they're a bit more spaced out. They might be sort of touching by fingertips only, spreading out. Gas! Everybody goes nuts, you spread out, you go everywhere, okay? Quite a fun game.
So, we have completely covered the idea that when a material changes from solid to a liquid to a gas, it can be thanks to a change in temperature, air pressure around it, and it's all to do with the atoms and the molecules and the space and energy between it. Now, that's the three states of matter, solid, liquid and gas. You will hear of other states of matter.
Absolutely.
And Emily, that's okay.
It's okay.
Some of the popular ones that are being mentioned now are Bose-Einstein condensate and plasma. Okay, but here's the thing. Whereas solid, liquid and gas is to do with the space and energy between the atoms and molecules, when we look at plasma, it's actually to do with what's happening inside the atom that makes up the molecule or makes up the material. So it is slightly different. And there is lots and lots and lots of other states of matter out there. This is a great opportunity to send your students out to do some investigating and to either work in small groups or as individuals. And what they can do, Emily, is just research what other states of matter are out there. And when they come back and share their findings with the other groups, they notice that they've got things slightly different, and this is quite exciting.
Google it, you'll see.
Because the thing is this is quite sort of fresh science, and scientists are saying slightly different things. And again, that's okay because we're defining this down and working out what's happening around us.
Excellent. So, Alan, what's over there?
What?
Where is it? Ah, here it is.
Yeah. Oh, yes. So here we have this wonderful thing, and we're going to learn a little bit more about this. So Emily, what is this?
This is a present from our friends the Kovacs. It is a teacher, but it's also very handy because it's got the periodic table on it. Now, to be honest. A few years ago, I couldn't get my head around the periodic table. I've always understood tea towels, unfortunately, but the periodic table was a bit different. It took me a bit of a while to get it, but I've found my own way to understand it. And the cool thing is, I actually share that process, that aha moment with the students in the show. So, my way of understanding the periodic table. I call it the cupboard of the
universe.
The cupboard of the universe. And I do that because it's like a cupboard, right? So when I'm hungry, I go to our cupboard, I grab the ingredients I need, put them together, and make something nice to eat. So they come together to make something new. Everything I need is in my cupboard. The cupboard of the universe has everything you need as well. It has all the atoms listed that we understand everything in the universe is made up of, right? So let's say, for example, I want to make water, the water molecule, H2O. So I go to the cupboard, I grab 2 hydrogens, H2, 2 hydrogens, 1 oxygen, I put them together and I make the water molecule. Now, as you know, so small, we can't see them. Lots of those molecules make a drip of water. So H2O, 2 hydrogen, 1 oxygen. Now, they call these formulas. I call them recipes. You can totally steal that. They're like recipes for a molecule. You can see the theme of cooking here. I'm all about it. Okay, so, thank you, Alan. You can put that down now.
Cool.
So in our show, we do talk about the periodic table, which is really great. Some kids know about it, some kids don't. That's absolutely fine. We also extend the kids because we do a classic experiment. Now, vinegar and baking soda is an experiment that most seniors, to be honest, have either seen or heard about.
Yep.
We've been doing this since kindergarten, but anyway. But you can extend your kids by thinking about the materials before they mix. So, down here we've got vinegar, and here we've got baking soda. In a minute we're going to mix them together, but let's look at the materials first. Alan, have you got the little formula for me, the little recipe? So in here we've got baking soda, also called sodium bicarbonate. Now the recipe, the formula, is this. This shows how those different atoms are linked together, joined together to make the baking soda. Oh, shame. This is vinegar. Ooh, sorry. This is a recipe for vinegar. Thank you, Alan. He's looking at me like I've lost the plot. Alright, so vinegar is actually only made out of carbon, hydrogen, and oxygen. Only 3 different types of things. But they come together in a certain number, in a certain way to make vinegar. Not baking soda, vinegar. Now let's look at baking soda. Thanks, Al. Sorry about that. Now, baking soda is that white powder in your cupboard, also called sodium bicarbonate. Now, that is made out of sodium, hydrogen, carbon, and oxygen. Alright, so they come together and make baking soda. Now, let's mix these 2 together. Are you ready?
Yes.
Okay. So when we mix those 2 materials together, whoa, that happened quickly. You can see that they have changed. Okay, so down here it doesn't look like vinegar anymore. You can see all the fizzing and the foaming, and something has definitely happened up the top. No more vinegar, no more baking soda. 2 new materials. Down here we've got sodium acetate and water. That's that one, thank you. Oh. And up here we've got carbon dioxide, which is behaving like a gas. Let's have a look at carbon dioxide because that recipe is way simple. It's got 1 carbon, 2 oxygen joined together to make the carbon dioxide molecule. And you can see here that that's behaving like a gas. Right, can you just pop that there please, Alan?
Can't we leave it there?
Well, it's kind of blocking my... Yeah, okay, you can leave it there. Okay, so, students, well, people in general to be honest, are quite familiar with mixing materials by mixing and by temperature. Because we do it all the time, right? So a really fun thing you can do with your kids to get them thinking and send them away to do a bit of brainstorming. So I've got here materials that can change by temperature, materials that can change by mixing them together. So here, well, Alan, water for example, can we change that by temperature?
Oh, if I put it in my fridge, if I take water acting like a liquid state matter and put it in my fridge and it freezes, it turns into a solid.
Yeah.
And if I take liquid water and put it in my kettle, all the heat and energy turns it into a gas. And I can make a cup of tea.
Absolutely. What happens to our skin in the summer, Alan?
Oh, me being a little English boy, I get sunburn.
Yeah, exactly.
Go pink.
Sausages, don't even need to talk about it. It'll just make us hungry. But also mixing, we're thinking about cement. We're thinking about making a raro drink. Painting, mixing colours together. So your students will know heaps of stuff that can change by temperature and by mixing. But also we can change materials by pressure.
Yep.
This isn't something we really think about. And here comes the extra content I promised you. We're going to change some water by pressure.
So, Emily's right. We can change a material's state of matter by pressure. We know we can change it by temperature, and we know we can change it by mixing. We've seen those. We're now going to change a state of matter of a material by pressure. So here I have a glass of water, H2O, and it pours, it takes the shape of a container. I'm now going to put it in this little device here, which is called a vacuum jar. In a few moments, I'm going to switch on the vacuum jar. That's going to suck out all the air from around it, and we're going to watch what happens. So the only thing we're changing is the amount of material, the air around it. We're going to remove all of that and get rid of it, and we're going to observe, we're going to watch what happens to the water. So Emily's going to quickly turn into camera person and just move the camera.
Vacuum pump, right?
And I'm going to turn on the pump.
Excellent.
There we go. So once Emily gives me the thumbs up, we'll turn on the pump.
I think that'll work, Alan.
You ready?
Yep.
Cool. Here we
do
go.
it.
So let's turn on the pump. We are now removing all the air from around the water. We'll just let that do what it does. You can start to make some observations. There is a slight change in the water.
Yeah.
Yeah.
I can see like little bubbles.
You can see little bubbles.
That's cool.
Oh, there. So, we can see the bubbles in the water. I'm just going to seal this off like so. And turn that off. So, those bubbles you can see is actually the water changing state of matter. It is changing from a liquid into a gas. Now, we have seen the water change from a liquid into a gas by removing all the air around it. What I'm going to do is I'm just going to take the tube off. I'm going to let the air back in, and I want you to watch what happens to the water, and then we'll speak about it from there. Watch closely. Wow, that was pretty cool.
Pretty good.
So we're going to get the camera back into position so you can see our beautiful faces. No laughing out there, teachers. There we go.
I'm really laughing. That was a really cool experiment. I think that's good, Al.
Cool. Come and sit down then, and we'll have a little chat about what's going on.
Excellent.
Cool. Excellent. So we saw the bubbles start to form. And that was the water changing from a liquid into a gas. And all because we removed the air around it. So, the air we breathe, Emily, is a mixture of materials.
Yes, absolutely.
And all those materials have properties, different ways of behaving, and they have mass. They are actually made up of something.
Yep.
So the air we breathe is a mixture of materials, and gravity is pulling them down to the ground.
Yep.
And at the moment, gravity is pulling them down, and they're pushing against the water and creating pressure. So the heat and the energy in the water has not got enough force to push against the air. So everything stays where it is. So due to the air pressure pushing down on the water can't push back. Okay? It's trying, but it can't. But when we create a vacuum and we remove all the air from it,
you don't have that pressure pushing down.
You've
right?
had a brain explosion. We don't have that pressure pushing down from the air. So now the energy and the heat in the water has got nothing to push against, so it now boils. So it is possible to change a state of matter of a material by pressure, and we saw it there in the vacuum jar.
That's cool.
Yeah.
As you can see, the What's the Matter show is a bit of a roller coaster ride. How long does this take? 45 minutes?
45 minutes. It's
Woo!
amazing.
That's pretty cool. There's a whole heap of demonstrations and experiments, and through those demos and bad jokes and stuff, we all talk about how we experience materials. We talk about the properties of materials. We talk about the states of matter. We talk about how materials can change through mixing and temperature, also pressure, but we focus on mixing and temperature in the show. We talk about atoms and molecules, how they're the smallest identifiable thing and everything's made up of them. We talk about the periodic table, which really should be called the
cupboard of the universe. So, if you want to learn more about all of the shows that we do and you want to make a booking, please visit www.scienceinavain.co.nz. That's www.scienceinavain.co.nz, or you can email us at contact@scienceinavain.co.nz.
I think they got it. Hey, we really hope you've enjoyed today's Science in a Van Live and learning more about our show, What's the Matter. Now, as we've said numerous times, What's the Matter is based on the material world part of the curriculum. But next time on Science in a Van Live, we're going to be focusing on the physical world. Right?
Ooh,
Don't hurt yourself. We're going to be focusing on forces. So
cool.
we're actually going to be talking about two of our forces show. First one's a bit of a crack up. It's the storytelling actually for juniors, and that's called Billy Goat Scruff.
Love it.
It is actually really fun. And our other show called Move It for senior kids about forces, and you'll get to meet our very famous, world famous in New Zealand, rubber chicken space chick Steve. So please.
I heard he was a hit with the chicks.
Yeah, you get the idea. Alright, so this is Science and Van Live. We cannot finish without Joke of the Day.
Joke of the Day.
Drum roll please.
So, Emily,
I'm ready.
two atoms were walking down the street. Two atoms were walking down the street. One atom said to the other, I've lost an electron. And the other one goes, are you sure? He goes, yeah, I'm positive.
Awesome. That's pretty good actually. See you next time.
Hey.